Chapter 9, Sections 2 and 3, we're going to learn about arithmetic and geometric sequences. So the first one we're going to look at is arithmetic sequence. So an arithmetic sequence has a common difference. The formula for the nth term is this. So this is the important formula that you guys need to know, write down for the quiz, have it memorized, whatever you got to do to remember it. A of n is the nth term of the sequence. A, so this A is our first term of the sequence, and D is the common difference. So an example of an arithmetic sequence would be like 1, 3, 5, 7, 9, where to go from 1 to 3, we're adding 2. To go from 3 to 5, we're adding 2. To go from 5 to 7, we're adding 2, and to go from 7 to 9, we're adding 2. So here, 2 would be our common difference. So the 2 would be our D. D is equal to 2. Our first term of the sequence would be 1. And our A of n term would come in handy if we were asking a question like, what is the 100th term of this sequence? Then we could plug in A. We would plug in 100 for n, because that's the term that we're looking for. And we could plug in 2 for D. And we could find out what the 100th term of this sequence is. So an arithmetic sequence is when we add numbers. So we add the same number, the same common difference between the two. So let's look at our first example. So we need to find the 10th term of the arithmetic sequence. So the first thing we need to do is find out what our common difference is. So to go from 2 to 8, we add 6. To go from 8 to 14, we add 6. And to go from 14 to 20, we add 6. So D is going to be equal to 6. So I'm going to write our formula over here. We have A of n is equal to this is A plus n minus 1 times D. So A of n is going to be the 10th term that we're looking for. So we're looking for A of 10, our 10th term. Our A, so this one, is the first term. So our first term in our sequence here is 2. So we're going to plug 2 in for A. Then we do plus. We're looking for the 10th term. So n is going to be 10. So we have 10 minus 1. And then we said our common difference is 6. So D is 6. So our 10th term is going to be 2 plus 10 minus 1 times 6. So we need to do what's in the parentheses first. So 10 minus 1 is 9. And then we need to multiply 9 and 6 together. So 9 times 6 is 54. And then we add 54 and 2. So our 10th term of the sequence would be 56. Another way we could have solved this problem was this is our first term, this is our second, this is our third, this one's our fourth. We could add 6 again to find our 5th term. So we would have 26, then we would add 6 again, and we would have 32. And we could just keep adding 6 until we get to our 10th term, and that would work. But if we were looking for, let's say, like our 50th term, that would take a long time to just keep adding 6, keep adding 6, keep adding 6. So that's where this formula comes in handy. So we need to find the 10th term of the arithmetic sequence. So the first thing we're going to do is find out what our D is. So to go from 15 to 23, we're adding 8. To go from 23 to 31, we add 8. So D is equal to 8. Our formula is A of n is equal to A plus n minus 1 times D. So we're looking for our 10th term. So our A of 10. This one, remember, is our first term. So our first term here is 15. So we're going to plug 15 in for A. Our n is the number of term that we're looking for, which is 10, minus 1 times D, which we said was 8. So the first thing we need to do is subtract what's in the parentheses. So we have 9 times 8. Now we need to multiply. 9 times 8 is 72. And then we add 72 plus 15, 15 plus 72, and we get 87. So our 10th term here would be 87. Arithmetic sequence. Example 3. What is the 100th term of the arithmetic sequence that begins 6, 11? So to go from 6 to 11, we're adding 5. So our D is going to be 5. Our formula that we use is A sub 10 is equal to A plus n minus n minus D. This is our formula. Now we need to plug things in. So we're looking for the 100th term. So our n is going to be 100. So we're looking for our 100th term. Our first term is 6. So that's our A. And we have 100 minus 1 times D, which we said was 5. So we have 6 plus 99 times 5. So 6 plus 99 times 5 is 495. So our 100th term in this sequence is going to be 501. All right, next we have geometric sequences. So in the first one we learned, an arithmetic sequence, that's when we keep adding the same number and we have the common difference between numbers. In a geometric sequence, we have a common ratio. So this would be like we multiply numbers. So if we had our first term, let's say, was 2, and our second term was 4, and our third term was 8, and our next term was 16. To go from 2 to 4, we're multiplying by 2. To go to from 4 to 8, we're multiplying by 2. And to go from 8 to 16, again, we're multiplying by 2. So this would be a geometric sequence because we multiply to get to the next one. This is our formula for geometric sequences. Again, we have A of n is equal to our nth term of the sequence. So that's what we're going to be looking for. A is our first term, and R is our common ratio. Okay, how to find R is important. So one trick that we can use is we take the second term and we divide it by the first term. So we have 6 divided by 3. 6 divided by 3 would simplify to 2. For the next one, we have 12 divided by 6. 12 divided by 6 simplifies to 2. The third one, we have 24 divided by 12, and that simplifies to 2. Then 48 divided by 24 simplifies to 2. So our ratio here is 2. So that's just a little trick for how to find the ratio. So example 4, we need to find the 10th term of the geometric sequence. So here, what we're going to do to find what our ratio is, we're going to take 12 divided by 4. 12 divided by 4 is 3. The next one, we can just check to make sure that we have the same ratio all the way around. So we have 36 divided by 12, which simplifies to 3. So our ratio is 3. We're going to plug it into our formula, which is a of n is equal to a times r raised to the n minus 1 power. So here we're looking for the 10th term of our sequence. So we're going to have to find a of 10, our 10th term. Our a is our first term, which is 4. So we're going to plug 4 in for a. Our r is our ratio, which is 3. And our n is the number of term we're looking for. So we have 10 minus 1. It's important here that we follow our order of operations. So our order of operations are, please excuse my dear Aunt Sally, if anyone remembers that from middle school. So we have parentheses, exponents. So in this one, the first thing we have to do is our exponent here. Before we can multiply that 4, we need to do the exponent first. So we have a to the 10 is equal to 4. Now we need to figure out what 3 raised to the 9th is. So again, we're going to use that x raised to the y button in our calculator. So we're going to click 3, then that x raised to the y button, and then 9. Then equals, and then that'll give us what 3 raised to the 9 is. So we have 3, x raised to the y, then 9 equals, we have 19,683. So then we multiply this 19,683 times 4. So our 10th term in this sequence is going to be 78,732. So we need to find the 7th term of the geometric sequence. So the first thing we need to do is find out what r is. So we're going to do negative 3 divided by 1. Negative 3 divided by 1 is negative 3. Again, just to make sure that we have the same ratio throughout, we're just going to do 9 divided by negative 3. 9 divided by negative 3, again, is negative 3. So our ratio is negative 3. Remember our formula that we're going to plug in. We're looking for the 7th term now, so n is going to be equal to 7. But our basic formula is a of n is equal to a times r raised to the n minus 1. So our n is 7, so we have a to the 7 is equal to, a is our starting number, so 1 is equal to a. So we're going to plug 1 in for a. And our ratio is -3, so we have -3 raised to the 7 minus 1. Seven minus 1 is 6. So here, when we put this into our calculator, we're going to hit -3, that x raised to the y button, and then 6, and then equals. So when we put this in the calculator, we get 729. So we have our 7th term is 1 times 729. 1 times 729 is just 729. So this is our answer. Any questions here? So for all of these types of problems, all you need to do is find the parts of the formula. So this is our formula. You need to find the a, the r, the n, and then just plug them all in. And then from there you can just put in your calculator.